All right, in this module, we'll continue our exploration of the pandas data frame object, and the focus here will be filtration or filtering our data sets. Basically, that means taking a subset of our main data frame based on a certain condition being met, or perhaps not met, or perhaps multiple conditions being met. We'll explore all the different ways that we can essentially take a larger data frame and extract those rows that match a specific condition, kind of looking at a subset of our main data frame. Let's begin by creating a brand new Jupyter notebook. So I'll click the new button on the right here and select my Conda root environment. Here I'm going to give my notebook a name. Let's call it DataFrames 2 once it loads. All right, DataFrames 2. Let's of course import our pandas library and give it an alias of PD. I'm going to click escape here to go back into command mode and hold my B key a little bit to create some cells below for us to work with. And let's call our read CSV method on our pandas library and import the CSV that we'll be using throughout this module. And it's called employees.csv. So I'll just type a little bit, press tab, let's press shift enter and take a look at what we're working with here. So this is a fictional list of employees from a fictional company. We have about 1,000 rows here and 8 columns. You can see we have the employee's name, gender, when they started at the company, which ideally should be represented as a date, their last login time into our fictional system, their salary, which is an integer, their bonus percentage, which is a floating point number, whether they're in senior management or not, which ideally should be a Boolean value, and their team within the company. So let's go ahead and assign this to a variable. I'm going to use df because it's short and sweet. It's a pretty popular variable name among people who use pandas just because it only takes 2 characters. And let's also make sure we have the first 3 rows visible with the head method just so that we have a quick refresher of what this data frame looks like. So there's 2 things that we can do here. We can actually call either the info method or the dtypes attribute. I'm going to call the info method because it's a bit more comprehensive. And the reason I want to do this right now is to take a look at the data types that make up our column and see if there's any opportunities to optimize them. So first of all, what we can immediately tell here by the different values that we see right here is that there are some columns that are going to have missing values. We can see that there are only 855 non-null values in gender compared to 1,000 non-null values in start date. So there are, something like 140, 145 missing values in the gender column. We also have a couple other issues here. We can take a look here, for example, at the senior management column, which is being imported as an object, which means string, instead of as a Boolean, which is a more lightweight data type. We can also see that our gender column is being imported as a string, and that is a column that is really optimal for converting into a category, which we discussed in the previous module, because among these 1,000 rows, there's only going to be 2 values for gender, male or female. Technically speaking, there's going to also be the null values, but we can pretend as, okay, three different values, male, female, and null, but still a very small number of unique values across those 1,000 rows. And finally, perhaps the most critical thing here is you can see that the last login time column and the start date column are both being imported as strings. So when Pandas is looking at something like this, it's not seeing August 6th, 1993. It's just seeing a bunch of numbers and a bunch of slashes together as characters. This isn't really ideal. Now, the reason that we are going to run into an issue here, in this tutorial perhaps we won't because we're not going to do any kind of date-related operations, but our goal is always to have the data in the most flexible shape. And if something is meant to represent a date, we want to store it in a data type that's going to be convenient to that. So when we have a string instead of a datetime object, for example, we're not going to be able to do date operations like adding a date or subtracting a date, calculating the distance or duration between 2 days, figuring out what year a day falls in or what month a date falls in. Right now it's a string. That's just a bunch of characters. It's no different from any other word like hello world. So what we want to do is convert the start date and last login time columns into date times, which is a specific object that we'll dive into a little bit more later. But basically that just makes it adaptable to date operations. Right now it's not. So let's begin with that operation. I'm actually going to call the toDateTime method on the pandas library. toDateTime is basically a method that accepts an input and converts all of the values in there to datetime objects. So I'm going to feed it my start date series. So df is my data frame and start date is my column. What I actually want to do here is just show you what this looks like, at least the first 3 rows here. So here's what we currently have. You can see that it is a string. And now what we're going to do is convert it to a datetime object with this method. So you can see the visual format is going to change a bit. Now we're going to have the year represented first, followed by the month and date. Here it's a little bit in reverse. But behind the scenes, the more significant change is that this is now converted to a datetime object. So Pandas kind of understands this now as a date, and it knows what it can do with it. It can do things like add a year, subtract a year, figure out things about it, what weekday, for example, this day fell on. You would never be able to do that from a string because a string is just characters. So now that I've converted this to a datetime, I can go ahead and assign it back to that column, df start date, and that's going to overwrite the values. And now let's do the same thing with the last login time column. So let's take a look at what it looks like. Here's my first 3 rows. You can see it's just representing the time of day. And I'm once again going to call my toDateTime method. It's directly called on the Pandas library, and one argument that you can give it is something like a Pandas series. And it's going to go through that entire series and convert every value to a datetime value. So we're giving it a series of strings, and we're going to get a series of datetimes back. Now, there is a little bit of a caveat here, which is because we're missing a date, Pandas is basically going to substitute whatever today's date is. So I'm recording this video on October 15th, 2016, so that's the day that's been substituted here. When you're watching this video in the future, your value here is going to be different. And certainly even as I record perhaps future videos here, you may see that the value here is going to change. The date component is going to fluctuate. That's not a problem. We're not going to be specifically focused on this column in this module. Just keep in mind that whenever you're giving the toDateTime method a series of strings, in this case that only have times, it's going to have to fill in a time or a date rather for that, and that date is going to be today. So once I'm satisfied with this, I can overwrite the value in my last login time column. And let me just delete this cell. Let's see, what else do we want to do? There's a couple things we want to do. One, senior management, as I mentioned, is currently being stored as a string. You can see the object there. And this is much better represented as a Boolean. A Boolean is much more lightweight as a string. So once again, I can do as type. I can give it an argument of bool. This doesn't have to be in quotes again, but I prefer it to be. So there we have our new series of Booleans. I can reassign that new series back to senior management. And finally, as I mentioned, the gender column it really only has 3 unique values, male, female, or null. So what I can do is render it as a category, which is going to create 3 unique objects and point every reoccurring value or duplicate value to one of those 3 objects, which saves us a lot of memory that it doesn't have to store all of those strings separately. And of course, none of that is made permanent until I reassign back to the gender column. So here I have these 4 operations on 4 separate series, and I've modified them all a little bit. And let's take a look here. If I go up here, I'm just going to create a cell here above. We can see that we currently have 62.6 as our memory usage. When I re-execute the info method, you can see that we've gone down to 48.9. So let's take a look. If I divide those 2 numbers, I can see that I've actually reduced my memory usage by almost a quarter, at least 22%. So right now it may not be a lot because we're dealing with only 1,000 rows, but you can imagine how much quicker Pandas will operate if you have 10 million rows and you've reduced its total memory by 22%. So whenever you're importing a data set, always watch out for things like that, little tricks that you can do to reduce the memory usage. So what I'm actually going to do is I'm going to copy these lines of code to the very top here, because basically this is going to serve as our re-execution code at the start of each lesson to ensure we're always in the exact same shape. So let me copy this, and then I'm going to show you one more trick that I can do. I wanted to show you the toDateTime method just so that you have an understanding of how it works, but there is actually a shortcut that we can use in our readCSV method to avoid doing these operations separately. So the readCSV method has a parameter called parseDates. It's parse_dates, and what you can give it is a list of strings where every string will represent a column name within the data frame. And what it's going to do is those columns it's going to render automatically as datetime objects. So for example, instead of writing these 2 commands below, these ones that we just did, what I can do is just write start date as my first string value, which is my first column, and then last login time as my second column that I want to be interpreted as a datetime column. And now when I re-execute this, there we go. I'm going to delete this, and when I execute the info method, you can see that those columns are being rendered automatically as date times, so I don't have to call the toDateTime method. So everything now is exactly the same. We can see our memory usage is as it was. These two columns are date times. This gender column has become a category. Our senior management column has become a Boolean, and so on and so forth. So we've optimized it a bit. In fact, if you want a little bit more practice, you can practice, let's say, creating a category for the team column. There doesn't seem to be that many unique teams in that column, so maybe that's another idea of something that you can convert from a string to a category to reduce memory usage. It's really up to you. But that's just an introduction to our data set, our employees data set that we will be using throughout the next lessons. And we'll begin this module with an exploration of some of the basic ways that we can filter and extract a subset from this main employees data frame. So I look forward to continuing our exploration of pandas, and I'll see you in the next lesson.